In my previous videos on MongoDB sharding, I received many requests that how can we apply MongoDB replication on different AWS EC2 instances. MongoDB replication was already there in the plan, so finally I have come up with MongoDB replication video. Let me show you what is MongoDB replication. What are key terms which one should know when talking about MongoDB replication, replication strategies, and demo on AWS Cloud? This is what I am planning to do in this video series on MongoDB replication. Now let us proceed further. What is replication? Replication is nothing but automated copying of the data. This is client application, you can say this is web application or some client accessing our MongoDB cluster. So in MongoDB cluster we have primary, the concept of primary, as well as secondary. There are in this diagram or in this picture you are able to see one primary, two secondary, one, two, right? So once the client is writing data to primary, it goes to secondary 1, secondary 2 also. But this replication is asynchronous. We will talk about this in the coming slides, but for now you can understand that client is writing through primary, it is writing to primary. Secondaries have already established connection with primary, so these nodes are copying data from primary. How that we are going to discuss. Replication also represents redundancy and data duplicacy from one instance to another instance. Now, can you imagine that what will be the benefit of this redundancy? Before I move to the next points, data availability will be the biggest benefit. We will not lose any data in case we have multiple copies of data, same data. A group of MongoDB processes, right? One MongoDB process is running on primary, another MongoDB processes are running on other secondaries as well. How read capacity is increased? Because we can configure this cluster or client to read from primary as well as secondaries also in parallel for different use cases. Now let us move towards key terms. First key term which I am going to describe is heartbeat. So how these nodes in replica set come to know that the other node is working, right? Or secondary comes to know that this secondary is working, right? Or primary is working, primary knows that both of secondaries are there, and or if any of these are not working, then there must be some action to be performed. That also is done using this heartbeat. All of these are sending heartbeats to each other so that they come to know that yes, the other node is alive. If not, then there is a need to do something. Maybe some alert can be generated, right? Let us continue with operations log, which is another important term. It is a special capped collection which keeps a rolling record of all operations in the databases. So means that it records all the operations happening in the database so that other nodes can copy this, can refer this and copy this. Records the operation on the primary's oplog. So these are the secondary nodes which are copying or referring this primary's oplog and copying it. Copy and apply, right? In asynchronous process means it is not that as soon as the data is written on primary it is getting copied. So it is the data is written into primary, and it is just a lag of some time, maybe in milliseconds or seconds, that secondaries start reading the data from the primary's oplog. Moving further, priority. Again, this is another important term. It helps to decide if node can be elected as primary or not. So primary means that if primary goes down due to some reasons, then which node will become primary, right? So priority helps us in doing that, in selecting that, and we need not to do that manually. We just need to configure those things at the time of configuring the replica set, or maybe later also, and then based upon this priority, it will automatically check that which secondary node is eligible, or there could be more than one eligible secondary nodes also for the to become primary, right? So that also can be decided based upon priority. So a priority 0 member cannot become a primary. So this point, please make a note of that, that a member with priority 0 cannot become a primary, and it cannot trigger elections. For example, a primary has gone down, then in that case the other node with priority 0, it cannot trigger election also. It cannot tell the cluster that yes, I want to become primary, and it cannot trigger elections. That is what it means is. However, it can acknowledge write operations issued with write concern of W. We will see that what is write concern, and it must have voting rights. Then only it can acknowledge the write concern. It maintains a copy of dataset, accept read operations, and vote in election. The members with priority 0 do everything except becoming a primary node or triggering the elections. Otherwise, it can do all the things like copying, accepting read operations, and ensuring that it can participate in elections, provided it is configured to do that. Use case for setting priority 0 in the replica set for some of the nodes is that nodes are distributed across data centers, and we do not want a remote node, right, to become a primary. There are two data centers. One data center is having multiple data nodes or located near to another data center, and the third data center is far away, which we have just kept for precautionary measures to avoid unforeseen data loss, right? So in that case, we do not want that particular data node to become primary. So in that case, we can keep that node's priority as 0, or maybe that node is set up to serve the local requests of that region, that is just for serving the reads from that particular region, which is quite minimal as compared to main nodes. Another is hidden replica set members. These are also maintaining a copy of the primary's dataset, invisible to client applications. Though these set members are hidden, right, they can store dataset also, but they are not visible to client applications. Client applications cannot send read to these hidden replica set members. This is good for workloads with different usage patterns, which is different from primary. Priority 0. They can also vote in elections or configured to vote in election. they don't receive any traffic, right? They cannot receive any traffic, direct traffic to themselves other than the basic replication. They can just copy the data from primary's oplog. In case we want some client to read it from it, that is not possible because these are invisible. Then you might be wondering that why we need these hidden replica set members. This is the use case, reporting and backup, right? In reportings and backups, we may not need the live data. We can assume that in case the data is 1 hour old or 1 day old, right, then that should be fine for reporting. And backup, in case we lost the data, primary goes down, and then we have some copy of data in some hidden replica set members. This can also acknowledge write operations, provided again these are having voting rights. Now another one is delayed replica set members. Delayed means it can or it will have a copy of the replica set primaries data, but it will be delayed. For example, in case we have in case primary is having data till 9 a.m., then this secondary, which is delayed, it will have data till 8 a.m., right? So this secondary is delayed by 1 hour, correct? So this is how delayed replica set members will work. Now again my question is, you can pause this video. Without moving forward, can you think of a scenario where this delayed replication may be required? It may help recover from various kinds of human errors. Again, it must be priority 0 members. Now if you think over it, or if you recall, you can see that how important priority is, right? For hidden members also we set priority 0, for delayed also we are setting priority 0. That means it cannot become primary. Again, must be smaller than the capacity of the oplog. It must be a hidden member. The amount of delay must be equal to or greater than the maintenance window duration. So this is the question which I want you to answer. You can think through it and answer in the comment section of this video that why the amount of delay must be equal to or greater than the maintenance windows durations. Okay. Write concern is basically, it describes the level of acknowledgement for write operations. For example, this is the client which is trying to write, right? It applies the write to primary and replicates the data or replicates the data to secondary, right? And again at this point in time, so this is the time, you can say that first this much time it is taking to write to primary, then replication starts and return to secondary. Now again it starts moving towards this another secondary, but at the same time we want to send acknowledgement to driver or client who has sent the request that the write has been written successfully, or I am acknowledging the write, right? This primary has to send back. Once this primary, now you can see this with dotted arrows, this secondary has sent a response to this primary that data has been copied. This secondary has not done that because the configuration is done in such a way it is saying W majority. In these three nodes, W is 2. Once data is written to two nodes, it can send acknowledgement back to the client. That is what is meant by write concern. Write concern has many values which can be configured. It says that W value, right? J again journal, it means journal, whether that write is meant to write to journal of primary, secondary or all the nodes, right? Or then this timeout, that after how much time, in case there is no acknowledgement, the operation has to time out. Maybe 30 seconds, maybe 50 seconds, right? That is what can be used. In JavaScript or Node.js drivers, MongoDB drivers, this can be configured, or this can be configured at the time of setting up the replica set also. Just similar to write preference, we have read preference also. That means how MongoDB clients route read operations to the members of a replica set. That is, this is client, this is another client, and this client is using default read preference, which is primary, right? That means this client will always send requests to this primary only, while here the read preference is set to nearest. That means this client can send to whichever node is nearest to this client. That is how read preference will work. That is how parallel read can happen from primary as well as secondaries also. I am going to show you different options, like default is from primary, nearest is nearest node to that client. Same way we have other options also that I am going to show you in next slide. All read preferences mode except primary may return stale data. Please make a note of this. This is very critical. In case you want to read from anywhere except primary, beware that it can return a stale data. It does not affect the visibility of the data. Read preferences primary, which is the default mode, and it will always read to primary. Primary preferred, client will send requests to primary if available, else operations read from secondary members also. Self-explanatory. Secondary, all operations read from the secondary members rather than primary. There are cases where a read from secondary members does not matter. There we can use read from secondary members and we can configure this, right? Why? Because there might be requirement of reporting and other things. Secondary preferred, in most situations operations read from secondary. If no, then this. Same way nearest also. Now there is a concept of arbiter also. While setting up the replica set, there could be chance that project is running out of budget and they don't have the budget to set up a new node, data node, right? In that case, there can be a use of arbiter. This arbiter will ensure the requirement fulfillment for the number of nodes required in a replica set, as well as the number of voting members required in the replica set, as well as other conditions also. So this arbiter does not store any data and it will always be an arbiter. It cannot be converted into a data node later. It will always be an arbiter only. Like I mentioned, cost constraint, it does not hold data, it is just the node. It participates in election, its default priority is 0, and it's it has exactly one vote. Automatic failover, how does it happen? Let us say, as I mentioned earlier, that these secondaries are not able to send or receive heartbeat from the primary. Then it assumes that primary has gone down, and any of these secondaries, provided they have that priority set, they can trigger election, and now this new primary has been selected, and this happens automatically based upon the configurations, priority of the node, right? All those things. How data sync happens: when a new node joins the replica set, it populates new member with the full data set, copies all the data from one member, clones all database. Replication, then once this initial sync has happened, it will start replicating as per the configuration. So synchronization is of two types. One is initial synchronization, then is the replication that we have been discussing. And there is nothing additional one has to do. As soon as the data node has been added into the replica set, it will automatically start initial sync, and then later on, once initial sync is completed, it will start copying replication from the primary or any other data node. Now these are the strategies for replica set deployment architectures, or we will have to decide the number of members, voting members, right? Replica set can have up to 50 members, maximum 7 voting members. Replica set will not allow you to make 8th node as the voting member. Odd number of voting members, again a question for you, that why there must be odd numbers of voting members in the replica set. Use hidden and delayed members for the dedicated functions, right? Add capacity ahead of demand. You should not wait until the replica set members are full of its capacity and it starts throwing error. Whenever replica set members reach up to 50% or 60%, don't wait it to go until 70% of usage, then otherwise there might be some issues. So keep capacity, add capacity well ahead of time. Distribute members geographically. All the members should not reside in one data center. They should be having data spread across geographically. Journaling. Use journaling to protect against power failures. Again, it is related to this only. Load balancer. So use read preference, appropriate read preference. It could be nearest, it could be secondary preferred, primary preferred, primary, right? Now I'm going to show you one example, that 3-member replica set, how we can deploy. And please make sure that replica set has at least 3 members in the production setup or in the pre-production environment, so that all the things are tested successfully before going live. In 3 members replica set, with all the 3 members storing data, one will be primary and 2 secondary members. Either can become primary in an election, provided both of secondary members are having priority greater than 0 as well as voting rights, right? And these are configured to do that. Same way option 2, where only two members are expected to store data, one is primary, another secondary. In that case we will have to use arbiter for that. My favorite part in this whole video, where I used to check your knowledge level, I come to know your understanding level also. So you can pause this video, read these questions and answer in the comment section of this video. Now replica set demos. All these steps are available on my GitHub page also. I'm going to show you replica set up on 3 nodes cluster, arbiter, member. We will add and remove members. And please feel free to ask any questions or doubts where you are having. So I will try my best to answer your questions. Let us proceed to demo now. Okay, now I am going to launch the instances. So number of instances I want to launch 4. This is the new interface, by the way. I can opt out to the old experience as well, right? So let me move with this new instance only. Name and tag I want to add like replica set demo, mongo replica set demo. I want to have ubuntu. Which type? I want to have ubuntu server. T2 micro, and please note that it says that free tier eligible. Key pair options I want to use. I will have create a new pair. Private key file format I want to have demo AWS create key pair, and you can have .pem file in case you are using Linux machine to connect from your desktop or laptop. Allow SSH traffic from anywhere, right? Allow HTTPS traffic. So right now I am allowing only SSH traffic. Configure storage, that is what we want to use. Free eligible customers can get up to 30 GB, or we are using only 8, that is fine. Advanced details, don't need to worry about this for now, and let us launch these instances. One thing which we will have to do is we will have to allow the ports on which we want to run our MongoDB instances, replica sets, right, on those security groups. We will have to allow inbound traffic to those. Yeah, these are all running. So I will rename it replica. I will name it as replica 1. Replica 1. Save. Replica 2. So I will name it as primary. This I will name as replica 3, and I will say later. Let us allow inbound traffic. So edit inbound traffic here, edit inbound rule. So which ports I'm going to use, let me just check quickly. 28041, and I will allow 28041 custom from anywhere. 28042 again anywhere. or you can run this on same port also, but I'm doing it right. Allow anywhere. Please make sure that in production setup you are not allowing it from anywhere. It should be only application server URL, or it should be within a VPC. So I am saving this rule. Going to EC2 instance, running primary. I'm going to use MobaX, so this I will rename as, let us say, primary. Okay, I will copy IP also. This is the IP. Okay. Okay. Now I will connect to this primary, edit session. I will use this private key. Okay, double click on this and it should connect now. It has connected. I will have to install MongoDB also. Again, all those commands are mentioned here. There is another video where I have covered how to install MongoDB on Ubuntu machine. Assuming that you have MongoDB installed, let us proceed further. Create directory in every node here. All the nodes, I am creating a directory. In 3, I am not creating a node for now, directory for now. So starting this node, starting MongoDB process on first node, let me copy primaries full name and IP also. This I will keep it here and here also. Don't worry, I will show you that. First let us start this MongoDB process on primary node. Make sure that you are running the right command on right node. So this is primary. Again, this I am going to run on this. You can use this command ps to list processes, then grep mongo whether it is running or not. In our case it is running. So let us go to replica 1 and note down its public DNS and replace it in the next one, IP, and replace it in the second node here. Copy this command, assuming that DB path, you can have any other DB path. I am referring the same directory which has been created, replica 1. Make sure you are connected to replica 1 and start it. Again, you can verify this with this command, and you can also verify that ls lt. You can see that after this replica set has member, and member has so many directories or files, journal file, right? And it has created some collections also at the configuration level. Now moving on to third one, replica set 2, DNS, copied, and IP also copied. And now let us start this one, third replica set. Again, make sure that DB path and the name of replica set, and now this replica set name should be common. It can be any name, but this property should be the same, right? So you can have any name to identify your replica set. Let us check once again. Right, so now let us connect to any one of these. I am connecting to this one and clearing. I'm connecting to this MongoDB process running on this port and this host. Let us see whether we are able to connect. We are, because I have opened the ports. I have opened the inbound traffic to this port. I have allowed that. Now this part, I am with this command, I am going to show that I am defining configuration, name of replica set which should be same, and then what are the members. There are members id 0, it can be anything, right? And I am pressing OK. Configuration defined, and using this rs.initiate command I can start that. Now with rs.status I can see the status of that. Secondary and secondary. Right now all the nodes are being shown as secondary. Now you can see that primary, right? So this node has become, and if I run that rs.conf, it will show me all the details. Name of replica set, members, correct, host name, arbiter only, whether it is arbiter, or build index is hidden, true or not, priority, what is the priority. We can set its priority as 0, 1, so that it never becomes primary. All those things we can configure here. And secondary delay seconds, it is not mentioned. Voting rights, again all of these are having voting rights as 1. So I hope so far it is clear to you, right? Now let us start the fourth one also. Now the fourth one we are going to show. Let me just check whether I have installed Mongo on this or not. Sorry, I will check with Mongo. Yeah, Mongo is installed. It is trying to connect to this. So Mongo is installed. So add an arbiter, create a new instance, make directory on this node as well. Now let us copy the fourth one also, IP and public DNS. The name of replica demo, name of replica set should be same. Let us start this also, and please make sure let us not use port number this, let us use 27017, because we have already allowed that port inbound traffic. So this I will copy, and okay, and IP also I will copy. So we can run either this to add arbiter or the following command, right? So first of all let me start this. Let us check, copy this command, paste it here. It is running, port number 27017. So let us add arbiter from here. Please make sure that you are back to your cluster where you have connected to Mongo SH here. So here we are defining rs.arbiter. This is the syntax, add arbiter, and the name. Let us see if we are successful in that. it says that reconfigure a template to install a config that would change the implicit default write concern. Default write concern we will have to change, so I will change that using this command. So what it does is that set default write concern 1, sorry, default read write concern is 1 and default write concern is 2. Otherwise there was some issue, right? Let me run this add arbiter once more. This time it should succeed, and yes, we have succeeded in that. rs.status. Now let us see. Replica set demo, all these things. Writable voting member count 3, voting member count 4, right? All those things. Why writable 3? Because arbiter cannot assume the data, correct? And you can see that primary, secondary 1, secondary 2, and this is the arbiter. This is how we can add arbiter here. Now let us remove that arbiter. rs dot remove. I will copy this and remove this. Status, again 3 nodes, correct? So this is how we can add an arbiter and remove an arbiter. In case we want to add the normal dataset member, that also we can do that using rs dot add command rather than the other one. Let me do that. Let us try to add another replica set member. It says added. Same node which we have added or removed, same node which we have added and removed from the replica set as an arbiter. Now we are adding that node as the data member just for the demonstration purpose. So you can see that it says that not reachable. There might be some issue. Let me just check. Mongo is not running on this. Let us run the Mongo on this node, then we should be able to do that as well. Maybe Mongo has been stopped here. Okay, now let me just try to do that, and you can see that total, again, voting members count 4, writable voting members count 4. Now this time it is different than the previous one. Earlier it was 3 here at the time of arbiter, now it is 4. Now again remove this node. Removing this, removed, and status again. There are 2 secondaries only, 3, correct? So this, we can also change the host names later on, right? In case any of the instance goes down, we can change it like this one, host name, rename that, and right, that way we can do that. So I think with this I will stop here, and I think you have a fair understanding of the MongoDB replication over AWS EC2 instances. Please note that this should not be replicated exactly as is in the production environment, because we have not applied any security here, right? Our voting members, all the nodes also have voting rights. Please make sure that you configure all the options based upon your requirement carefully and securely. That will help you. In the end, thank you so much for watching this video so far, and I hope that you have liked this video, you have gained something out of this, and you will share this video with your friends and in your network. And please share your feedback in the comment section of this video so that I can improve on. And please stay tuned, there are a lot of interesting content coming on your way, and I am also feeling grateful to you all for sharing your feedbacks, which has motivated me to keep going. And you can also consult me for any big data, Node.js, JavaScript, AWS related work. I will be more than glad to assist you, support you. Thank you so much for watching this video. See you, love you all.